Hello everyone, welcome to lecture 5 for mathematics of grade 9. In this video we are going to solve some of the exercises of section 5, which was about parallel lines and proportionality. So if you remember from previous video, we talked about proportionality theorem and even the converse of proportionality. So I strongly recommend you to take a look at that video so that you can understand the way of answering these questions here. So question number 1 says find the length KL in this triangle. So KL is over here. As you see, this line is parallel to this line because of this notation. The symbol here means these two lines are parallel. So we can write down the proportionality and find the length of KL, right? So for convenience, let's call KL X. Okay, so if you remember, proportionality goes like this. LK over KH equals L, so this vertex is not given, so let's call this vertex some letter like, so L is here, K, H, G, let's call this one J, so this point here is J. Okay, so let's write the proportionality. LK over KH equals LJ over JG. So LK divided by KH, this must be equal to LJ over JG. Alright, so now let's replace the values. LK is X, we are going to find this one. KH is 8 equals LJ is 4 and JG is 6. So let's cross product here. We'll get 6x equals 4 times 8, 32. Therefore, x equals 32 divided by 6, which is the same thing as 16 over 3, and that's the value of KL. Next question. Find the length of Rn. So Rn is this one. So this question is just like the previous one. You need to just write down the proportionality and then a cross product will solve the equation for you. So let's write down the proportionality. Let's call Rn x. So it's Mr divided by Rn equals Mq divided by Qp. So now let's replace the values. Mr is 10, Rn is x. This must be equal to Mq is 8, Qp is 5. So now just cross product. So 8x is equal to 10 times 5, which is 50. So x becomes 50 divided by 8, which is the same thing as 25 over 4. So, and that's the value of Rn. Question number 3 says verify that CD is parallel to AB. Okay, so this question is sort of the converse of proportionality. Here we don't know that this line is parallel to this one or not. We're going to verify this. So if you remember, the converse of proportionality says if EC divided by CA equals AD divided by DB, then CD is parallel to AB. So let's write these ratios and see if they are equal or not. So EC So we have to check this one. EC over CA, is this equal to ED divided by DB? So we're going to check this ratio, proportionality here. Let's replace the values. EC is 6.3 divided by CA is 2.7. Is this equal to ED is given by 7 divided by DB is 3. So one way to check this is to divide 6.3 by 2.7 and then divide 7 by 3 and see if you get the same numbers. But maybe that's a little bit harder approach, but there is another easier way here. You can always cross product because multiplication is usually simpler than division. So if you multiply 7 by 2.7 and that number is equal to 3 times 6.3, then this proportionality holds. So let's just cross product here. If I multiply 7 by 2.7, the answer is, so 7 times 2.7, is this equal to 3 times 6.3? So if you multiply 7 by 2.7, the answer is 18.9. If you multiply 3 by 6.3, the answer is also 18.9. So yes, these two are equal. Therefore, CD must be parallel. So remember, this symbol stands for parallel to AB. And so that was the converse of proportionality theorem that we had in the previous video.